Okay, we're on to our second video, section 1.2. But before we get into 1.2, we're going to do a little bit of factoring review. So if you guys remember our Xbox method of factoring, so for this first one, we're going to go ahead and draw our box, draw our X. So X squared goes in the top left, 18 in the bottom right, 9x goes in the bottom of our x, and then we take our first and last term and multiply them together, so 18x squared. And I want to think about what multiplies to 18 and adds to 9x. So this would be 3x and 6x. We plug those into our missing boxes. Now we want to see what we have in common. So for our top one, we have x and 3 in common, and then for our sides, for our top one we have x and then 6 in common. And so since both 3 and x are positive, this factors into x plus 3, x plus 6. Now for the second one, we do the same thing. We draw our box, draw our x. We do 4x squared in the top left, positive 3 in the bottom right, negative 8x in the bottom of our x. Now we take 4x squared plus 3, so that gives us 12x squared. So we want what multiplies to 12 adds to negative 8. That would be a negative 6x and a negative 2x. So we plug those into our boxes, negative 2x, negative 6x. Now we want to see what we have in common between 4x squared and 6x. So that would be a 2x, and we want to keep our first term positive. And then what do we have in common between negative 2x and 3? There isn't anything, but if you notice we have two negatives, so this will be, we'll pull out a negative 1. And then here we can pull out another 2x, but then this would be a negative 3. And so our factors would be 2x minus 1 times 2x minus 3. Now for example 3, if we go to set up our Xbox, we put 3x squared in the top left, negative 3 in the bottom right, 5x in the bottom of our x, and then negative 9x squared. But do we have any factors that can multiply to negative 5 and add to 5? We do not. So then this is not factorable. So for certain things, if it's not factorable, that is the end. But as we will see later on, just because something is not factorable does not mean that we can't do anything. So for 1.2, we're going to get into functions and graphs. So a relation is really anything that is related. But then a function means that for every input has exactly one output. So if we look at these relations down here, for example A, we see that each of our inputs on the left side has exactly one output on the right side. So even though both negative 6 and 6 go to 36, that's still okay. So this is a function. But for example B, if we see Clinton, Bush, and Obama each have two Supreme Court justices, and so this is not a function. Okay, so going on to the next page. So even if something is not a function, we can still say what the domain and range is, keeping in mind that as we list our domain and range, these need to be in numerical order. So for A, I'm going to use D for domain. Our lowest x value is 2, and then our next value is 9, and we use our little squiggly brackets. And then our range, we go from lowest to highest. So this would be from -5, 4, and 5. Again, using our squiggly brackets. But if we notice, 9 has 2 different values, so this is not a function. Then for B, we do the same thing. We want to put them in order. So our domain, our lowest x value is 0, then 2, 4, and 5. And for our range, our lowest value is -2, then 1, 5, and 7. And if we notice, each of our x values has exactly one y value, so this is a function. And then for C, again, we write out our x values in order, so -5, 0, and 6. But our range, we only have one y value for all of these, so we still use our little squiggly brackets for 3. And even though each of these x values have the exact same y value, this is still a function because all of our x values only have one y value. So our notation for functions, input is always going to be our x values, output is y, and domain is always associated with inputs or our x's, and range is our outputs or our y's. And so f of x represents our y values. So if we have f parentheses 0, this is read as f of 0. So we plug in 0 for all of our x values. So this would be 2 parentheses 0 squared minus 0 plus 3. 0 squared is still 0. We can go ahead and subtract these. So 0 plus 3 is still plus 3. This would be 0 plus 3. So f of 0 is 3. -7, f of -7, we would do 2. Be sure to use your parentheses for this one. So 2 times -7 squared minus -7 plus 3. Keeping in mind that when we square a negative, that's -7 times -7, so this would be 2 times a positive 49. Then plus 7 plus 3. 2 times 49 is 98, plus 10, which would give us 108 for f of -7. Then f of w, all we are doing is plugging in w for x, so this would be 2 times w squared minus w plus 3. There are no like terms, so that is our answer. For f of 5a, we are plugging in 5a for x. Anytime we have these parentheses, we are plugging in whatever is in the parentheses for x. So this would be 2 times 5a quantity squared minus 5a plus 3. So this would be 2 times 25a squared minus 5a plus 3, and then 2 times 25, so we have 50a squared minus 5a plus 3. Since there are no more like terms, that is our answer. Now for C, we're going to plug in a minus 4 for x, so this would be 2 times a minus 4 quantity squared minus a minus 4 plus 3. You can either use your distributive property or your xbox to multiply a minus 4 squared out. But this would give us 2 times the quantity a squared minus 8a plus 16. We need to distribute that negative because we have this parentheses, so this would be minus a plus 4 plus 3. Now we need to distribute our 2. So this would be 2a squared minus 16a plus 32 minus a, and we can go ahead and add these, so then plus 7. Now we still have some like terms, our negative 16a and negative a, so then this would give us 2a squared minus 17a and 32 and 7, so plus 39. And that would be our answer. Now, if we have a graph, we want to look at what our x value is and find our y value. So, as you can see, this is already sort of laid out here for f of negative 3. We would go to negative 3 on our x, see what our y value is, and that would be 3. So we want to do the same thing for b. We go to 2 on our x value, see what that gives us for y, which would give us a negative 2. So going on to the next page, we have our vertical line test to see if it is a function or not. If a vertical line intersects with our graph more than once, then it is not a function. So no matter where we put a vertical line on A, it will not cross it more than once, so this is a function. Here we see it crosses it twice, so this is not a function. This one also crosses it twice, so not a function. Again, if it crosses it multiple times, not a function. For C, since these are all straight lines, this is a function, and no matter where we would put our vertical line, it would not cross it more than once. For F, since this bottom is an open circle, then this is a function because we do not have multiple values for negative 1. If this was closed in, it would not be a function. And then we will finish up talking about domain and how to find domain in class. Thank you for watching.